This is Anshuman, and as per my earlier A-level video of the paper number 3 prediction, um, this is the additional portion which I am adding for the OCR students, right, who will be giving. The first portion you have to go through quickly was PV equal to nRT. In PV equal to nRT, we have to see that pressure should be in pascals, volume should be in meter cube, and temperature should be in Kelvin always, not degree centigrade. Then polar and non-polar molecules was a little bit tested, right? In your earlier papers, right? This portion is very important because this will be connecting with the intermolecular force of attraction, right? There are three kinds of intermolecular force of attraction we know: London dispersive forces, dipole-dipole, and hydrogen bonding, right? These three will be mostly tested, right? Hydrogen bonding is the strongest attraction forces, intermolecular force of attraction. Now come to the enthalpy changes. As I discussed in the earlier video also, that calorimetry experiment, right? Enthalpy of neutralization. Here we need the limiting reactant, right? To divide it. Q is equal to mc delta T. We divide this by 1000, we are getting kilojoules. Then we are dividing this with number of moles, we get the enthalpy change. Displacement reaction we discussed earlier videos, combustion enthalpy, solution enthalpy, and unfamiliar Born-Haber cycle. Mainly you go through MgO, or you can take calcium oxide. Hmm, You can take potassium oxide, right? These are uncommon, not unfamiliar. Electrode potential is a good thing. They will be testing for the A star questions. Combining with, go over the fuel cells which are there, hydrogen fuel cells, storage cells which are there, such as the batteries we have. Equilibrium constant we discussed in the earlier video of the prediction. Um, for the OCR guys, this is mainly for the OCR. I'm just telling that the KC will be tested. Transition elements. What are transition elements? Transition elements are those which has got an incomplete D in its elemental form or most stable ionic form, such as zinc. Zinc has got a electronic configuration of 3d10 4s2. So it has got a complete D. So zinc is not a transition metal. Even when zinc loses 2 electrons, zinc will lose 2 electrons from the 4s. So 4s is gone, the electronic configuration. So it got 3d10. So 3d10, still it is a complete D. So it is not a transition metal. Transition metals are those which have got variable valencies, number one, which has got colored compounds. So zinc is not colored, see, it's white. See, copper is a transition metal, right? Third, it can be used as catalyst, right? Fourth, it has got magnetic properties. Now, alkanes are free radical substitution, right? This mechanism, go over it, right? Methane plus chlorine or ethane plus bromine. Alcohols will be tested heavily, right? It's a very favorite question of the exam setters. A primary alcohol, secondary alcohol, tertiary alcohol. That primary and secondary alcohol can be oxidized, but tertiary cannot, right? We discussed this earlier. Yes, nitrogen compounds, right? Amino acid, right? In the amino acid, this will be also linked with the chiral carbon, right? That amino acid is what? The C double bond OH. You're having R, you have got H, you have got NH2. Now, amino acid, what changes? Students, what changes? Tell me, students. R group changes, right? Nitrile is what? Nitrile is C triple bond N, right? When you're stepping up the carbon-carbon bond formation, that also I've told you in this prediction for the OCR mainly, that we can describe different ways of adding C double bond C, such as we can do a nucleophilic substitution reaction with a cyanoion, right? Understood? We can use Grignard reagent. Do you get my point? CH3 CH2 Br. At Excel also, right? Grignard reagent also important. Plus Mg gives you CH3 CH2 MgBr. This is a Grignard reagent, right? When you make a Grignard region, by default, what happens? This bond breaks over here into CH2 minus and MgBr plus. This acts as a nucleophile, CH2 minus. This acts as a nucleophile to an aldehyde, right? Or to a ketone. And a nucleophilic addition reaction occurs, not substitution, addition reaction, aldehyde and ketone, right? So, yes. The third way is that if you have got a benzene, how to add C bonds. If you have got a benzene, we have to add a carbon-carbon bond. So what we do, we go via a electrophilic substitution reaction. What happens over here? H is substituted by CH3. So we go via electrophilic substitution reaction. What we take the help of? We take the help of the Friedel-Crafts reaction. What we take? We take CH3Cl in presence of aluminum chloride or FeCl3, right? So see, we have added a carbon-carbon. So this will be very important, right? Chirality, we know that. What is the chiral carbon? A chiral carbon is a carbon which has got all four groups different. Something like this, guys. This is a chiral carbon, right? A chiral carbon is a carbon which has got all four groups different. And if we have got the same molecule, remember one thing, this trick also you can understand, you can keep it. You have to take 4 electron domains for this, right? Always, right? A chiral carbon, you don't never search in an alkene. Never search in an alkene. Alkene has got 3 electron domains. Got it? It is sp2 hybridization, right? We're having. And 4 electron domain is what? sp3 hybridization, right? And it is 109.9.5 degrees, right? Isn't it? This. So always search chiral carbon in 4 electron domains as per the Vesper theory. And if you have got the same molecule, it's a mirror image of it. These two are called as optical isomers. You learned that. What are optical isomers? Optical isomers are those which turn the plane polarized light. This is. So it's ordinary light. You put a polarizer, we get the plane polarized light, right? So we have to be very sure of drawing the chiral carbon, right? See 2-hydroxy propanoic acid. We first draw propane, then we put oic acid, then we put the hydroxide into the second carbon. Then what we do? We then complete the chain like this. See, this is a chiral carbon. A chiral carbon is a carbon which has got all four groups different. So this is different, this is different, this is hydrogen, this is different, this is oic acid, this is different. So arrange the molecule in this manner in the center of the chiral carbon, put a mirror, then we just put the mirror image. So these are the two optical isomers. So that's a very important point for to note, that when we are going for this chirality, right? This is a very strong point of the all the AQ as well as Edexcel also. So I hope that I could really whatever could analyze, right, and give suggestions. I hope that it helps. So best of luck for all the students. You have really worked hard, right? A levels is quite a deeper portion, right? Best of luck for your 2025 paper number 3. Thank you so much. Thank you so much. Thank you so much to everybody, right? Thank you so much. Thank you. Thank you.